Good morning, all of you. Today, we are going to see next part of abrasive water jet machining, AWGM. So, we'll start with the elements of abrasive water jet machining system. Okay, we have already studied that the equipment used or the setup of abrasive water jet machining. Okay, this diagram I have explained in my previous lecture. Okay, so in continuation of this setup, today we are going to see the what are the different or various elements of abrasive water jet system. Okay, and you can see in the slide. First one is the pumping system. Okay, then another is the abrasive feed system and water jet nozzle. Okay, so we have the catcher. So these are the four elements, main elements of abrasive water jet machining system. Now let us discuss one by one. Okay, first is the pumping system. Correct. So whatever the pressure of the water is there, no, in that. So there, that pressure we have to maintain as high as up to 415 megapascal. Okay. So to increase the pressure of your water, okay, we require the intensifier. Okay, and through that intensifier, you can rise your pressure of your water up to 415 megapascal. Okay, so for that motor is required, and the motor of around 75 hp it is used. Okay, as we have shown seen in our water jet machining also. So it gives a high velocity jet. Okay, using this pumping system you will get the high velocity of your jet. Okay, so this is the first element, that is pumping system. Let us discuss the second element, that is abrasive feed system. Okay, abrasive feed system is this one. Okay, so here we have seen in the figure of our abrasive water jet system. Okay, so there it delivers that abrasive feed system. It delivers the dry abrasive particles. Okay, to control the flow rate of your dry abrasive particles. There we require the orifice that to control that we require small orifice. Okay, so you can see here also we have used here small orifice. Okay, and also we should have the a mixing tube, okay, to control the abrasive flow rate. So here we have the one mixing tube. Okay, for this you can change, if you want to change that or control the flow rate, we can change the diameter of orifice. Okay, it cannot supply abrasive over long distance. Okay, otherwise what will happen, your kinetic energy will go down. Okay, so we need abrasive feed system. Okay, the basic, once again I'm telling that the purpose of this abrasive feed system is to deliver the dry abrasives. Okay, and to control the flow rate, we should control the your orifice diameter. Okay, if you change the orifice diameter, definitely your flow rate is going to change. Okay, so to control, here I have written the point, to control the flow rate of your dry abrasives. Okay, uh, we should control the orifice diameter, and also we need to control the suction pressure in this orifice, sorry, in this mixing tube. Okay, and we cannot supply abrasive over long distance. Okay, as we know that. And whatever the nozzle is there, no, so that water jet nozzle diameter we should keep 75 to 635 micron. Okay, that care we have to uh, keep into the mind. Okay, so this is a abrasive feed system. Okay, here you can see the diagram, abrasive supply hooper is there. Okay, that is a feeder. Okay, and then through this you can see this arrow I have given. So through that you will get the high pressure water. Okay, and in the mixing tube here, or in this mixing chamber, the mixing of water and abrasive will be there. Okay, and after that mixing, high pressure or high pressure abrasive water jet you will get from this nozzle. Okay, through the mixing tube. Okay, now let us discuss the next point, that is abrasive jet nozzle. Okay, so let us discuss the abrasive jet nozzle. So there are various functions are there of this abrasive jet nozzle. Okay, first one is mixing of abrasive and water jet, as we have seen. Okay, and then forming a high velocity jet. Okay, and as like water jet machining, here also the material of the nozzle are tungsten. Okay, then boron carbide, sapphire material you can use, or a very hard material also you can use for the your nozzle material. Okay, and there also we have to take the care of the material should be resistant for your wear. Okay, that can be used. Okay, again for high velocity, as we know that high life of nozzle, normally sapphire material is used, but it is more expensive than other material as listed in the during the water jet machining. Okay. Also, there are various kinds of abrasive jet nozzles are available. Okay, that we are going to see now. Okay, or we can call abrasive water jet nozzles. Okay, so here you can see it's the first one nozzle type. It is called a single jet side feed nozzle. Single jet side feed nozzle. Okay, it is simple to make, but it's a rapid wear at the exit part of your nozzle that is taking place. Okay, so it gives non-optimal efficiency of your mixing of your water and the abrasive, as well as that I just I told that you will get the non-optimal efficiency. Okay, so if you that mixing of water and abrasive will not be proper, then you will not get the optimal efficiency. So this is a first a type of your abrasive water jet nozzle. It is called single jet side feed nozzle. Okay, now you can see in the figure also, you will get the water from this tube. Okay, the I have written the water and the arrow I have given, and from the hooper you will get the that from your abrasive feeder you will get the abrasive. Okay, so from one side you are feeding the abrasive, so single side is there. Okay, and single jet, through the one single jet you are taking the water, so it's called single jets and side feed. Okay, because from the one side only you are feeding the abrasive. Okay, and then in the mixing. हा. पुढचं जाऊ Okay, and then in this mixing chamber the mixing of the water and abrasive will take place. Okay, and then through this mixing tube it will comes in this your nozzle, sorry, at the bottom of your nozzle, so tip of nozzle you can pour. Okay, and through this tip of your nozzle it will that abrasive water jet will strike on your workpiece. Okay, you can see here your workpiece is there, and you can see here abrasive water jet is hitting the your workpiece. So that time you have to maintain this standard nozzle tip distance or stand off distance. Okay, so it's a single jet side feed nozzle. Okay, once again I am repeating, you can see in this figure abrasives are coming from this port. Correct, as okay, and water is coming from the central port. Okay, this one. Actually, abrasives are coming from another side also. That sideway. Okay, because the this only this front side I am showing, and water is coming from the central port, and both of them are mixing somewhere here. That means the mixing area. Okay, now after mixing, they are going out. That means from this nozzle. Okay, and you can see on the outer side abrasive particles are there. Okay, here, here you can see average particle, and water jet is there. Here also water jet. Okay, so abrasive particles are coming directly in contact with the your nozzle surface. This is the nozzle surface. Okay, and inner surface of your nozzle. This means so here abrasive will directly contact with your uh, the surface of nozzle. So where of the nozzle will be there. Okay, and that will be more. And you can see the distance between the bottom face of this your nozzle and the upper face of your workpiece, okay, is called nozzle tip distance. And when this abrasive water jet when it hits the your workpiece surface, then only a removal of the material will take place, correct. Here one point we should note that the whatever the nozzle tip distance or standard distance is there, no, so it is not fixed always. Okay, when the jet is moving inside, and it that time we have to accordingly that, okay, that means when the material removal will takes place, so that time you have to maintain that nozzle tip distance. Okay, that means you that nozzle tip distance or stand off distance is not fixed. Okay, now another one abrasive jet nozzle type is the annular jet central feed nozzle. Annular jet central feed nozzle. So it gives a better mixing of water and the abrasive particle. But in this particular case, mixing is outside the nozzle. Okay, mixing is the outside nozzle. Okay, so it is less accurate, or it gives the less accurate mixing as compared to the earlier one. Okay, so in this particular case, annular jet central feed cut or the curve width is there, no, so that is higher as compared to the earlier one, this one. Okay, so here you will get the cut or the curve width, you will get the high, okay, as compared to this one. Okay, as you can see in this figure, clearly you will get the water is coming from this side. Okay, you can see water, and the abrasive particles are coming from the central port. Okay, now both of them are mixing here outside the nozzle. You can see outside the nozzle both are mixing each other. Okay, and you can see the divergence taking place over here. Okay, because of this divergence of abrasive water jet, what are the accuracy of the cutting is there also that reduces as compared to the earlier one type of the your nozzle. So now because of this is a less accurate, because what are the divergence is there, no, or the mixing it's that will happen or that will take place outside the your nozzle. Okay, so this is a second nozzle jet, abrasive jet nozzle. Then third one we have the multiple jet central feed. Okay, multiple jet central feed nozzle. Okay, so it is surrounded by multiple water jet. Okay, in a conversion annular. Okay, actually, so here now in this case you can see the water are coming from this side, multiple jets are there, and nozzle sorry abrasive jet are coming at a center. Okay, so mixing will happen inside only, so you can see the chamber in this mixing will take place in this region, and then it will come from the this surface, this bottom surface of your nozzle. Okay, so okay, once again I repeat, you can see what are the mixing is there, so that is better than your other nozzle also. Okay, because here mixing is happening inside the nozzle. Okay, and water is coming from the this annular side. Okay, you can see annular side, this is cut section. Okay, and from all around water is coming. Okay, so that is why it is called multiple jet of water, and through the centrally you will get the feed of your abrasive. Okay, So it is called multiple jet central feed. So here the mixing is there, so that is very good. Okay, because it is happening inside your nose. So these are the types of your abrasive jet nozzle. That means here, what are the jet nozzle we are using here? No, so it having the different types that we have seen. Now, last equipment of the this abrasive water jet machining, no, it is called a catcher. Okay, so let us discuss that catcher also. Okay, now we can see what is the use of the catcher. Okay, so the catcher is used to minimize the velocity of the abrasive water jet before it strikes the base of your water tank. I repeat, catcher is used to minimize the velocity of the your abrasive water jet before it hits the base of the water tank, so that tank does not get damaged. Okay, so here also we have different types of the your catcher. Okay, so you can in that we have the type that stationary nozzle and moving workpiece. Okay, you can keep stationary your nozzle and you can move your workpiece, okay, as per your required shape of the cavity. And another type is the moving nozzle and stationary workpiece. Okay, so here I have not shown the diagram. Okay, you can see here, here catcher. So it is used to minimize the velocity, okay, of your abrasive jet which is coming out here. Okay, before it strike the your uh, base of water, we need to reduce the velocity. For that purpose, catcher is used. And the type of the nozzle, so types of the catchers are: first is the moving nozzle and stationary workpiece, and second is the moving workpiece and stationary nozzle. Okay, so these are the type. Now let us discuss the next part, that is a parametric analysis, or which are the different process parameters that we will see here. So you can see here I have shown the fishbone diagram of abrasive water jet machining. Okay, or you can call it is parametric analysis of water jet machining or abrasive water jet machining. Okay, before we discuss it, let us first see what are the various parameters involved in the what this abrasive water jet machining or cutting process. Now, first of all, water is there. Okay, so these are the process parameter. Water is the process parameter. So in that water again, the pressure of the water, the flow rate of the water. So both are the parameters for this particular process. Okay, then we have the another the uh, water nozzle. Okay, so this is second process parameter. Okay, so in that again the material of your water nozzle, it is important as we have seen earlier in the average water jet and water jet machining. Again the cross section of water nozzle. Okay, so it can have this that cross section of the your nozzle. It maybe your circular or the cross section or rectangular. Okay, it can have the rectangular cross section also. Okay, then next process parameter is the hardness. So hardness of your workpiece is also very important parameter. Okay, again other material properties are also equally important. Then workpiece, whether it is brittle or hard, ductile. Okay, that will because the depend on the this brittleness and the ductility, that will decide the material removal rate and the mechanism of material removal. Okay, also. So these are the parameters, okay, which will affect the on your machining quality or the material removal rate or the quality of cut, curve width, then depth of cut. So these are the performance characteristics, okay, which will be affected by this process parameters. Okay, then we have the abrasive. Okay, another process parameter. So in that again, abrasive type of the abrasive which type of abrasive you are using. Okay, then you have the abrasive particle size. Okay, what is the absolute size or the mesh size of the abrasive particles? So that is also important. Then whether they are coarse or they are fine. Okay, so that also we need to, that is a type. Okay, that parameters also affect the performance. Okay, then the material of abrasive, whether it is silicon, carbide, or aluminum, or other type of abrasive. Okay, that is also important to know, because it affect the on your performance of abrasive water jet machining. Okay, then again the flow rate of the abrasive is another important parameter. So here I have written flow rate. Okay, then abrasive feed nozzle. Okay, you can see here abrasive feed nozzle. Okay, what are the cross sections of the abrasive nozzles and the materials of the feed nozzle? Okay, that is also we should know. Okay, so here I have written cross section of the abrasive nozzle and the material of the abrasive feed nozzle. Okay, that is also important process parameter because it is very hard. Okay, so then nozzle itself will wear out slowly, and you cannot control the accuracy accurately that average that feed rate. Okay, then we have the cutting parameters. Okay, like feed rate is there, the number of passes you have used, then angle of cutting. Here you can see then nozzle tip distance or SOD. Okay, so these are the cutting parameters which affect the performance of abrasive water jet cutting process or abrasive water jet machining process. Okay, then the mixing tube. So mixing tube diameter and the length of the this mixing tube, that also are both of are important parameters which affect the performance of your abrasive water jet machining. Okay, and how to measure the performance, or the what are the output or responses, okay, which are normally measured, and based on the which we can measure the performance of abrasive jet machining process. So that output responses means the your machining rate, then quality of cut. Okay, machining rate means the material removed, MRR. Okay, then quality of the cut edges, then curve quality, depth of cut. So these are the output responses of the performance characteristics you can call. Okay, so this is the important process parameters. Okay, through the fishbone diagram I have explained. So I request all of you, you will not get this diagram in any book. So I have taken from one of the I think one research paper. So I request all of you, please draw this fishbone diagram. Okay, I will give 2 minutes to draw this diagram. Please draw this diagram. Now let us go for next. Now we'll discuss the how these process parameters affect the performance. Okay, that is your depth of cut or maybe the MRR. Okay, so let us see the effect of pressure. Okay, on the depth of cut, effect of abrasive water jet pressure on depth of cut. Okay, as you can see in this particular figure, here is the one is the point which is written as a critical. Okay, you can see critical pressure. Okay, so this is a minimum pressure. Okay, unless the kinetic energy of abrasive particle crosses that this critical pressure, it cannot penetrate inside the workpiece surface. Okay, because already this point about the critical point I have explained in the during the abrasive water jet machining, abrasive jet machining. Okay, so until and unless your kinetic energy crosses this critical pressure, it cannot penetrate inside your workpiece surface. Okay, so that is why you can see there is no cutting in this particular zone, in this particular zone here. Okay, and that is the point before the critical pressure is reached. Here you can see critical pressure reached, and as the abrasive flow rate is increasing, the depth of cut is also increasing. But here also beyond a certain pressure, it is not a linear relationship. Okay, it is not a linear relationship. So this is a non-linear relationship, and it tries to stabilize beyond a certain pressure. And now you can see here also. Okay, abrasive flow rate increases, the depth of cut also increases here. And again, this is also not a linear. Okay, you can see here. So you can see here the minimum pressure or the critical pressure of or kinetic energy of abrasive particle needed to cut a material is there. So here, and it is difficult for a different material. The value of this, okay, it is different for different workpiece material. Now the same things you can see. So same thing will happen with the abrasive water jet machining. Okay, with your material removal rate. Okay, because as pressure is increasing, the depth of cut as well as the material removal rate also increases. But after a certain limit, the flow, the depth of cut, it will stabilize. Okay, so same things I have given here again the explanation that below the critical pressure no cutting is taking place. Okay, you can see in the slide, and critical pressure is different for different workpiece material. Again, it depend on the workpiece properties. Okay, and above finite jet pressure, okay, machine depth it will tends to stabilize, and the relationship with the machining depth is steeper, that means linear, uh, at higher abrasive water abrasive flow rate. Okay, and when increase the pressure will leads to higher cost, that will leads to the higher cost of your pump maintenance. Okay, and if the pressure is very high, then maintenance of pump becomes more expensive because of more wear and tear. Okay, again it gives a lower efficiency at very high pressure, and the higher nozzle wear rate is also observed with a very high pressure. Okay, and the below critical pressure, the stress developed in the workpiece is lower, okay, than the yield stress. Okay, and that is why you do not get any removal of the material below the critical pressure. Okay, and here you can see here water pressure water jet pressure versus depth of cut I have shown. So it shows the effect of water jet pressure on the depth of cut. Okay, so normally you can see in this diagram. So it initially increases if you increase the water jet pressure. Okay, it will increase the depth of cut, but afterwards it's try to stabilize. Okay, now you can also see that this is the nozzle diameter. Okay, you can see first d1 and d2 are the nozzle diameter. If nozzle diameter is larger, then depth of cut also decreases. You can see depth of cut also decreases, as you can see over there. It is because if the same power that the pump motor is there, then the pressure of the water or abrasive water jet coming out of is lower, and that is why the depth of cut is also smaller. Okay, then we have the another parameter that is called abrasive flow rate or water flow rate. So here you can see water is a profiling fluid, okay, that enables the high abrasive flow rate, and the flow rate you can have as high as up to 5 kg per minute. Okay, an abrasive velocity normally it is, as we know, that 300 meter per second. An abrasive water jet is current because more suitable for, because it is more suitable for cutting. So this is much more current as compared to the abrasive jet machining process. Now here you can see here, okay, water flow rate is directly proportional to water flow rate is directly proportional to uh, square root of pressure. Okay, and it is directly proportional to square of the diameter, okay, of your nozzle, that is d square, yeah, dn square. Okay, so the you can see again the machine depth is proportional to velocity of abrasive particle, okay, as well as the mass flow rate of abrasive particle, okay, that you can see in this formulas. And you can see again above the critical value of your mass flow rate of your abrasive particle, the depth of cut start decreasing. Okay, and if you increase in the mass flow rate, so then it leads to the wear of your mixing nozzle. Okay, and higher wear of mixing nozzle, it tends to reduce the mixing efficiency. So that is why there is always appropriate or the critical amount or critical value of your mass flow rate will be there. Okay, now the important thing is that how to select the type of the abrasive. So selection of the type of the abrasive, it depends on the cost of abrasive, then nozzle wear rate, then environmental consideration and the machining rate. Okay, so finally it is also operated by the particle strength also. So here I have written some parameters, okay, which we have to consider while selecting the type of the abrasive. Okay, then we have the another process parameter, it's called the abrasive flow rate. Okay, so you can see average flow rate is increasing, then depth of cut is also increasing in this diagram. Okay, in different kind of abrasive, say glass, here you can see the example, alumina is there, granite, silica, sand, glass beads. So different depth of cut you will get depending on the material also of your abrasive flow rate. Okay, so now you one thing is that you can see here the depending upon the type of abrasive, the depth of cut is different in the different cases. Okay, you can see in the diagram. For alumina, the depth of cut will be different than for the silica, sand or the granite sand, it will be different. Then let us go for next one, that is effect of this abrasive particle size. Abrasive particle size. So there is always optimal particle size for particular application. Okay, which include the workpiece material also. Okay, so in that again fine particle, you can see fine particles are used for shallow depth of cut, and if you take the coarse particle of your abrasive, then it is used for the high depth of cut. Okay, so different abrasive particle sizes are there for the different cut of depth of cut. Okay, that one we have to take into account. Okay, so different abrasive sizes for different depth of cut are also proposed by the some of the researchers. Okay, however, in practice, normally it seems to be little different difficult task. Okay, because how to take the particle size for different material. So the again the machine depth is there also, that is also the function of type of abrasive particles. Now another process parameter is called traverse speed. Okay, so traverse speed is the relative motion between your abrasive water jet and the your workpiece. So it can be achieved by moving abrasive water jet or workpiece. Okay, again in that if you see the relationship between the traverse speed or the traverse rate and the depth of cut, the this kind of relation you can see relationship between the traverse rate and the depth of cut. Okay, if you increase the traverse rate, depth of cut is decreases. Okay, if you see here also, as traverse rate is increases, area generation, this second ion area generation rate is increasing. So there is optimal area generation, and beyond which it start decreasing, beyond which it start decreasing here. Okay, and in this diagram I have shown the depth of cut decreases with the increasing traverse rate, which may be within 10 meter millimeter per second. Now okay, one thing here itself I have to clear that what is mean by traverse rate. Okay, so whenever above water jet and your workpiece, okay, so that will move in the direction of your, that means if you keep your uh, workpiece constant, and if you move your that water jet, okay, so that is called the traverse uh, speed. Okay, and that rate we have to consider. Okay, so these are the process parameters I have covered here. Okay, so this is about the water jet machining. Okay, already the applications I have covered here. Okay, it is used for non-metal, that is ceramic, composite rock, the metal. Okay, that is copper. So I request all of you please write down the applications of the abrasive water jet cutting or machining process. Okay, have you written all of you the applications? Again, I think we have not drawn this diagram last time because I have not given the time. So I will give time now. So all of you, please draw this setup diagram of abrasive water jet machining. Please draw this diagram. This is important. Simultaneously, you can write your roll number in the chat box so that I can take attendance also. Don't leave this meeting. Okay. First, complete this diagram as well as you, please write your roll number in the chat box. All of you, please write your roll number in chat box. Many of you have not written, I think, roll number. Only 20 students has given roll number. What about all other 7? If anybody remaining, please write your roll number. And those who have drawn this diagram and those who have written your roll number, you can leave this meeting. Okay. Here we'll stop for today's lecture. Rohan Gandole, have you written your roll number? Shivani Kothole, 6. Okay. Written. Mansi Bumkar, 19. Okay. Just time cross checking. Okay, no problem. You can leave this meeting. We will stop here.